Okay, the timing is horrible, but it is what it is. So you're just gonna have to find some time over the weekend or on Monday to do some practice, because it's gonna be really fresh in your mind. And actually, if you're able to stay after school and you wanna take it now, you can after school, if you wish. Otherwise, Tuesday it is. There are office hours on Monday. Okay, those are classes, there are office hours on Monday. Huh? Oh, we do have it on Wednesday, because Tuesday is, we don't have class on Tuesday. Yeah, so this group has it on Wednesday, you're right. That's even worse. Okay, so here we go. Practice test 3. Oh Lord, that's even worse. Wednesday, yep, all right. So here we go. Oh, actually, I don't need to write this one down probably. Is this growth or decay? Growth. What is the percent? 8%. What is the initial value? 16. All right, we got that? Okay. Next one. Write the equation of the exponential function. What does an exponential function look like? Just like that. Y equals a times b to the x. What do we do now? Plug in what?
2/3 into A.
2/3 is A. That's the initial value. So y equals 2/3 b to the x. And then plug in the other one. So 3/2 equals 2/3 b to the second. Now, I've got to solve that equation, which means I need to get rid of what? I need to get rid of that number right there. By?
2/3.
Not by 2/3, you would multiply both sides by 3/2. So, like, you can do that in 2 steps if you want. You can times by 3 and then divide by 2, but it's probably easier just to do it all at once. Because if you multiply by 3/2, this goes away. So b squared equals 9/4. And that means b is 3/2. So y equals 2/3 times 3/2 to the x. 2 separate numbers, right? Okay, now we have about a bazillion simplifies. So what are you going to do with 16 to the negative 3/4? Make it 1/16 to the 3/4. Never flip the exponent. I was grading some papers and people were flipping the exponent. Never, ever, ever, ever. What does that mean? 3/4 there. What does that mean? That means the 4th root of 1/16 cubed. What's the 4th root of 1/16? 1/2. Because the 4th root of 1 is 1, and the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. Now we gotta cube it, so our final answer is 1/8. Got it? 4 to the negative 3rd, easy. What's 4 to the negative 3rd? 1/4 to the 3rd, which is 1 over 4 times 4 times 4, 64. What about C? Just flip it, and since it's to the first power, that's all you have to do. So the answer would be 16/9. Right? Right? Don't make them harder than they are. Some of them are hard enough. Take advantage of these easy ones. Speaking of easy, what about D? 1/3. Because what happens when an L and an E touch each other? Gone. Yep. Okay, what about E? Set it equal to X and loop-de-loo it. If you don't know what else to do with a logarithm, loop-de-loo it. So 3 to what power is going to give me 27? 3. So the answer to that problem is 3. Okay. All right, what are we going to do with this next one? It is a mess. Let's see how much room I have. Yeah. Oh, yeah. All right, so what am I going to do? First thing I would do, and again, everybody gets to kind of do their own thing, but the first thing I would do is clean up the mess that's inside. So what do I do with an x squared over an x to the 4th? I'm going to simplify that, and they don't all cancel because I have more on the bottom, right? How many more on the bottom? 2, so I'm going to have 2 on the bottom. The rest of them are going to cancel. Now the y's are trickier. So since it's negative, y to the negative 5th or y to the negative 11th, aren't they both going to flip? So I'm going to have y to the 11th over y to the 5th. So when I start canceling, I'm going to have some extras somewhere. Where are the extras going to be? On the top, right? On the top. And how many extras will there be? 6. So I have y to the 6th on the top. Everybody with us to this point?
Yes.
All right, now I have to take everything to the 1/2 power. As far as the exponents go, I just multiply. So that's going to be y to the 3rd and x to the 1st. But what do I do with the numbers? What does 4 to the 1/2 mean? Square root of 4? 4 to the 1/2 means the square root of 4. So that square root of 4 is 2. Square root of 9 is 3. And there's your answer. G, another easy one. What's G? G is just 19, right? We're not going to miss that. G is just 19. What are we going to do with H? H is a little bit different.
Put base 10 settings for the x.
So Jordan says, first of all, the base is 10. And second of all, there's only one logarithm in there, so I want to loop-de-loo it. But in order to loop-de-loo it, I'm going to need to set it equal to x. So does all that make sense to everybody? So that's what I'm going to do. So here we go. Log base 10 of 100 equals x. So 10 to the x equals 100. X equals 2. All right, what are we going to do with I? Flip it, make it 5 halves. Squared.
25.
So 25 over 4. And then we have another easy one in J. J is 1/3. I'm so nervous about, you have all these days off. Please, 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 or I shouldn't say off, but these days away from math. Please take some time and look at this. Refresh yourselves. before Wednesday. Wednesday's 5 days away. All right, here we go. What are we gonna do with this guy? Loop-de-loop. So 2 cubed equals 2x minus 1. 2 cubed is 8. So I'm just gonna solve it now like every other equation. I got 9 halves. Charlie, you keeping up here?
Yeah.
Yep, easy. Well, B certainly doesn't look easy. What are we gonna do with B? Remember, this is only baby calculator, right? So we don't have our big calculator for this. So what are we gonna do first? Divide by 5. Always, always, always divide by that number. So 4 to the x equals 32. That's 160 divided by 5. Okay, now what? Now, she said log both sides. That will 100% work, but the problem is I don't have my calculator. So I can do the log, I can write log 32, but I can't do log 32 without a calculator. I need to get the same base. What base are we going to use? 2. Because 4 is 2 squared. And 32, you probably ought to know this, but if you don't, you can figure it out. Just keep multiplying by 2 until you get to 32. Anybody know how many it takes? 5. 2 to the 5th. 2 times 2 times 2 times 2 times 2 is 32. Now, once you get them both to be 2's, then you can 2x equals 5 and x equals 5 halves. Okay? All right, what do you want to do with the next one? First thing, get rid of that extra number. It's exactly like the one we just did. We have to get rid of the extra number. So the first thing we're going to do is divide it out. And let's see what we have left. So if I divide it out, I'm dividing both sides by -2, I'll have the log of x equals -2. There's a base of 10. Add 1 logarithm, so I will loop-de-loop. And what's 10 to the -2nd? 1 over 10 squared, which is 1 over 100. How come it's 1 over? Because the exponent was negative, right? And that's how I do negative exponents. I do 1 over. Alright, what are we doing with this guy? We're going to multiply both sides by 8, because what do I always have to do? Get rid of that number, right? Now somebody might say, I want to divide by an 8. Okay, but remember what Mrs. Field and your 8th grade teacher and your 7th grade teacher taught you? When you divide by an 8, you're multiplying by the reciprocal, right? You're multiplying by 8 over 1. So I'm going to end up with 2 to the 3x over 4 equal to 64. This problem is exactly like this one, you guys. I need to get a common base. And my common base will have to be 2. How many 2's does it take to get to 64? 6. Now, thinking, we figured out that it took 5 to get to 32. So is it 32 times another 2, 64? So if it took 5 to get to 32, it's gonna take 6 to get to 64. Okay, so then 3x over 4 equals 6 times 4, so 3x equals 24. So x equals 8. Okay, what about this guy? I heard someone say it. Who said that? Good job, Sammy. I cannot, you cannot, no one can do this problem the way it is. We have to combine those because we are only allowed to have one logarithm on each side. So I'm going to put these two things together and write one logarithm. All right? What's going to go in that parentheses? In other words, what happens when I put them together?
Division.
It's a division. So 2, always first over second. So 2x over x plus 1. Why is it division? Because that is a subtraction. Right, my friends? Okay. Now what? Loop-de-loop. So 4 to the third equals 2x over x plus 1. 4 times 4 times 4. 64 equals 2x over x plus 1. How are you going to solve that? Multiply by x plus 1. Now when you multiply by x plus 1, you guys, that's going to be a distribute. So 64x plus 64 equals 2x. So negative 62x equals 64. So it looks like if I reduce that, it looks like I'm getting x equal to negative 32 over 31. Beep, 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 beep. Extraneous, extraneous. Why is that extraneous? Can anybody tell me? Not because it's negative, but because when I put it back into the problem, this would be negative. You see, there's a difference. I can get, let's say I had a problem like this. Okay, I'm making this up totally. Let's say I solved this problem and I got negative 1 as my answer. That would be okay, because when I put negative 1 back into the problem, I'm logging a positive. This would be positive. This is what can't be negative. X can be negative, but this must be positive. Remember what happened when we did log negative number? That's what you can't do. You can't log a negative number. If I put negative 32 31st right here, wouldn't this be a negative number? And that's what can't be. That's what makes it extraneous. Okay? All right. Okay. What about F?
Combine logs.
Gotta combine the logs. It's just like the one we just finished. You cannot have this. This is not allowed. So log base 3 of something equals log base 3 of 5. What's the something?
X plus 1 over x.
X plus 1 over x. Are you with me, everyone? Okay, now, this is where it's different than the last one, because when we did this last time, we loop-de-loop. We're not gonna loop-de-loop this, cause it wouldn't make sense, because that's not a number over there. So what do we do instead?
Cancel logs.
We can cancel these out, and we have x plus 1 over x equals 5,
You know, only cancel those out because they're the same. They're
because
the
it's
same
log equals log. And I'm not gonna give you different bases,
base. Okay.
okay? That's a whole different animal. Doable problems, but on a different level than we're doing. So, if you have log equals log, you're gonna cancel them out. You do not cancel them out of the original problem, because this is not log equals log. If you cancel here, you will not get the right answer. Alright, what do I do?
Times X.
Times x
And minus X.
minus x divided by 4. Now, I want to show you something real quick. This is the answer to this problem. Alright, everybody got 1/4, we're good, perfect. If this had been x minus 1 in the beginning, then 1/4 would be extraneous. Because what happens when you put 1/4 right here? It's a negative number. So do you see what I mean? I'm not crossing things out because they're negative. Sometimes I have to cross out positive things. They get crossed out if they make this or this negative. Okay?
Will there be like problems like that on our test where we have to check?
Oh, you have to always check. You have to always check. It just happens.
And so if we get one that's extraneous,
Cross it out. Cross it out. And say no solution. Unless there were 2 solutions to start with and one of them worked. Alright. What's next? 4 to the x equals 8. What are we doing with this one? 4 to the x equals 8. Same base. And what base will you use? 2. So we have 2 squared to the x equals 2 cubed. And as soon as we do that, we have 2x equals 3, so x equals 3 halves. Leo, you already did that one? Good job, buddy. Leo's usually always on target, always working hard. I see him sitting back there like this. Alright, ln x equals 2. The base on that is e. So e squared equals x, and I'm done. That's x. I'm solving for x. What does x equal? E squared. And I'm not even gonna write down because you should be able to do I. The answer to I is 49, 7 squared. Right? We all good? Okay. Number 5. Stop it. This is I was up way too late last night too. I had to go to the hospital and see my brand new granddaughter. Didn't I tell you she was born yesterday? During office hours, yeah. She slept through the whole time. We stayed because we were hoping she would wake up. But she'd eaten right before we got there, and she just slept and made those cute little baby noises. You know how they do noises. But then I got home and still had to do homework, so I was up a little later than usual. All right, I gotta write this as 1 logarithm. That's my goal. 1 logarithm.
X over Y up there.
I'm gonna have an x and a y in here, and they're gonna be divided, aren't they? Why are they divided? Subtracted. And then what about that 3? He's the exponent on y. Right? Do the same thing backwards for the next one. What's that going to be? I'm going to need a log x and I'm going to need a log y.
2 log x plus log y.
I'm going to add them.
And 2
Right, folks? I'm adding. And I'm putting the 2 out in front of just the x. I'm grading homeworks and I'm seeing these random coefficients. Remember, it goes with the letter it's on. So this is x, or this is x squared. So 2 is going to go with the x. All right, now we're going to use a calculator. Log base 6 of 13. There are 2 ways that you can do this. You can, but it's going to cost you 50 cents. Here, you can pay later. All right, so what are the ways we can do this? We did a couple different ways. If we remember, isn't this just going to be log 13 divided by log 6? That's our change of base formula, right? I gave away my calculator, so I need somebody to tell me what it is and then somebody to confirm that.
1.4315.
Round to the nearest thousand.
32.
So 1.432.
432.
Following directions.
Do you not do literature?
You can, we'll talk about that in a second. So if you remember the change of base, a problem like this will always be the log of that divided by the log of that. That one stays on the bottom. Okay? Now, Sammy says, over and over and over again, Mrs. Ford, you've told me to loop-de-loo when I have one logarithm. So if I do, Sammy, I have 6 to the x equals 13, which is perfectly fine. There's no common base. I can't like get 2's or something. So I'm going to need logarithms because that's how I get an exponent. So if I log both sides, that will come out in front, and look what happens. Don't I end up dividing log 13 by log 16? So you can absolutely do it that way. It takes a couple extra seconds to do, but then it's consistent with how we do all of our problems. This is kind of a little tricky thing you have to remember. But you don't have to do it that way. You can loop-de-loo it and divide. Okay? All right. Everybody good on that one? Okay. Now what? What are we going to do with this next one? We have to. Very good. Very good. Again, I know I have programmed you. You see that X up there and you say, ooh, we're going to need logarithms. But we can't do that until we get rid of this. So 3 to the X equals 15 fourths. Now, the only way to solve for that X is to get it down. And the only way to get it down is to put logs in my problem. So x log 3 equals log 15 fourths. And you are going to divide log 15 fourths by log 3. Now, does that make sense to you, everybody? You follow those steps? Yeah, I'm doing my calculator, so
1.2 of
1.2
203.
203. Anybody confirm that?
Yes.
Vanessa's nodding. I think Vanessa likes logarithms. So let me write that down. What did you say, 1.203? All right, Jarius, is that what you got? Yep, 1.203.
Yeah.
David, you get that?
Yes.
All right, one more on this page. Did you get 1.203? No, you got something else. What are you doing here? Type log 15 divided by 4, close parentheses. Divided by log 3.
I was doing another.
Oh, okay,
That's
okay,
why.
okay. I don't know what the answer to that one is. You might have been right. What's the first thing I do here?
Divide by 4.
Divide by 4. So e to the 1.3x equals 17 fourths. Now what?
ln.
Now I'll ln, because that will cancel those. And I have 1.3x equal to ln 17 fourths. So x equals ln 17 fourths divided by 1.3.
1.113.
1.113.
Yep.
Yep. Good. All right. So here's what I want you to do. I want you to read each problem and write down the formula you're going to use. Here are your choices. Okay, those are your choices.
Will we get these for the test?
Yes, I've said all along, you won't need to memorize these. But what you're doing right now is reading carefully and making a choice. So don't plug any numbers in and all that yet. Let's get the formulas for each problem first. And then if you wanna go back and plug in, you can, but I wanna make sure we all have the right formula. Because what happens if you have the wrong formula? Everything you write down is wrong. We don't want that to happen. So, problem A. What formula did you put down? Non-pert, okay, we'll be that non-pert. So this is gonna be problem A, right here, right? Y, what's the keyword? Compounded quarterly. All right, what about B? Same one, because it says compounded monthly. And what about C? That's your pert. Because it's not even money, right? So any question about that? Okay, then let's start plugging numbers into A. How long will it take an investment of 150 to double? Okay, wait a minute, what does that tell me?
You're starting with
I'm
150
starting with 150
and then times it by
and
2.
ending with 300? My interest rate is what? 0.0175. What am I dividing by? 4. And T is actually my unknown, which tells me that, like it or not, I'm going to need a logarithm, but not yet. What do I need to do first? Divide by 150. We talked about this yesterday. Did you have to be given a 150 to start with? No, it doesn't matter what you start with. Because if you started with 500, then this would be 1,000. And when you divide by the 500, you're still gonna get 2. When you are doubling or tripling or whatever, it doesn't matter what you start with. The time's gonna be the same. All right, now what? You gotta get that exponent down. So log 2 equals 4t log this. Now, it looks terrible. But why in the world would you want to type stuff in and get all these decimals that you round up? No. We don't need to write down anything else at this point. You know what you need to do. You're solving for t. So that means we have to divide by 4, right? That'll get rid of that. And then we need to divide by that to get t. So one of the other classes called it double divide. We have to divide by this and then divide by this to get t totally by itself. You don't need to write that down. You're going to type in log 2. Did you already do it? Log 2.
39.69.
Okay, I don't know. So write your number down and then I'm going to type it in.
Okay.
So log 2.
Does it matter which one you divide by?
Nope, it doesn't matter which one you divide by first. I'm just going to divide by 4 first. And then I'm going to divide by log 1 plus 0.0175 divided by 4. And I got exactly what Chloe got. She's going to read it and say it nice and loud, Chloe.
39.694.
Years.
95.
695?
Yes.
Years? Years.
So I'm taking log 2 and then dividing it by
4.
4.
Did you close the parentheses after the 2?
Yeah.
And then divide that answer by this right here.
That log and then.
Yeah, that whole thing. You're trying to get t by itself, so you gotta get rid of all of it.
What'd you get?
39 point something.
How do I do the 2?
Oh, because I didn't put log. I'm so smart. Good one.
Yes, that's my variable. That's what I'm getting by itself. So you're gonna do log 2 divided by 4. And then divided by that, log that parentheses. 39? Okay, we'll do it one more time, and then you're gonna have to get some help, okay? Start over, okay? Clear. Log 2. Jarius, log 2. Close parentheses. Divided by 4. Equals. Divided by. Log 1 plus 0.0175 divided by 4 equals. That's it. 39 point something. I don't remember, but it's 39 point something.
39.695.
Okay, so what we did, Jarius, was exactly what you would do when you solve any kind of equation. We took this number, we divided it by this, and then we divided it by this, so that all that was left was t, and that was our rule. All right, I have a feeling we're gonna be doing something similar, because we're using the same formula for b. B is using the same formula. So let's see. What am I looking for in B? I'm using the same formula. Oh, that's good. If I'm looking for A, then my troubles are over. Because I've already solved for it. It's already by itself, so I just have to type all this in. So 1 plus, what's my interest rate? 0.02, 125, divided by 12. And what's my exponent? 12 times 25, which is what, 12 times 25? Is that 300? And then, do we need logarithms or anything like that? No, we just type that in. And what is that?
$16,791.
$16,775.
$91.75.
Somebody confirm that?
Yeah.
Yep. All right. And then you said the last one we're going to use our PERT formula for. So what is that going to look like when I get it all set up?
8,888 equals 4,567 E raised to 0.234 T.
Uh-oh. I'm going to need logarithms, right? But not yet. What's first? Okay. Now, I know I'm gonna need logarithms, I might as well ln. So that goes away. So I'm gonna have ln 8888 4567 equal to 0.234t. So I need to divide by, now I got the hiccups, 0.234. And I'm gonna miss T.
2.8.
What'd you say? 2.8.
2.8. Yeah, 5.
2.845?
Yeah.
Anybody else get that?
Yeah.
Good. Majority is. All right, we just took the test. So, having done that, what extra problem do we need to do? And I'll make one up.
Can we do one if the y equals a times b to x? How long?
We have to write the equation of an exponential.
Yes.
Alright, so I have to give you a couple of times. Alright, so let's have 0, 1/3, and 2, 12. So we're gonna write the equation of an exponential. So as soon as you see those words, write the equation of the exponential function, you're immediately gonna think what? Y equals AB to the x, right? And then your immediate eyes are gonna look right here and say, whoop, there's my initial value. So instead of AB to the x, it's gonna be 1/3 b to the x. All right, and then what?
Plug in the
Plug in this point So 12 equals 1/3 b squared.
Divide that one.
Divide by 1/3 or multiply by 3. Remember, those two things are the same. So do whatever's easiest. I think it's easier to times by 3 personally. So 36 equals b squared, which means b equals 6. And that is not the answer. The answer is 1/3 times 6 to the x. All right, that didn't take very long. What else?
Can we
Solomon?
do a logarithm without a calculator? Like when problems, a log problem without a calculator.
So, give me a.
Like a non-calculated one that has logs.
Okay. So, like, I'm looking at problem number 4. Like which one of those? A or C or H or I or F or which one?
Like D,
D? 4D is not a logarithm problem.
I love the wrong test.
Okay. I'm on practice test 3, the one we just did.
C.
C? Okay. Okay, so let's say we had, 4 log x equals, 8. That's kind of easy. We'll do another one, that one's kind of easy. What would we do first? Divide by 4, so log x equals 2. And then we recognize our base is 10. So 10 squared equals x, and x would be 100. All right, what about something like this? 3 log base x of 9 equals 6. Oh geez, I hope this comes out right. Okay, so I divide by 3, so log base x of 9 equals 2. So then x squared equals 9, so x equals 3. And then one more. How to simplify. This won't be a solve, this will be a simplify. Something like ln 4th root of e cubed. Alright, so first of all, what does a 4th root mean? No, it does not mean negative.
The exponent?
4th root means 1/4. So this is e to the 3rd to the 1/4. What do I do with those exponents? Multiply, so e to the 3/4. But now look, what do I have right next to each other? An ln and an e. So the answer to the problem is 3/4. Now, you can't cancel the ln and the e because there's something in between them, right? So what was the very first thing I did? Got rid of that thing in between them by rewriting it as a 1/4 instead of a 4th root. Okay, is your hand up?
Like kinda, I do have a question. Like, could you do it backwards? Because like, if you started with it and it was like 3/4, that's how you would get it into that radical. Cause like the base or the bottom of it would be the
Yeah,
4th.
so this would be the 4th root of e cubed.
Yeah. Instead
Exactly.
of doing like the 1/4.
Yeah,
Do you have to show
Absolutely,
that?
you do. Cause you are doing that, Macy, you're just doing it in your head.
Okay, yeah.
That's what you're doing.
Do you have to show the second step?
No. No. A lot of people don't, a lot of people are gonna look at that and say the answer's 3/4.
Okay.
I'm gonna forget stuff already.
All right, you got time to do one more, even though someone's alarm's going off.
Can you do one of the expanding ones?
So, come on, last problem, we're paying attention. So she wants to expand log base 5 of 3x squared over y to the third. So what does expand mean? It means have, instead of one logarithm, have a bunch of them. You're gonna need 3, because you're gonna have, you have a 3, you have an x, and you have a y. Those are the 3 components of your problem. Notice, that 5 doesn't have anything to do with anything, except it's there. Now, I already put a plus in there, because what's happening here? That's a multiply, right? But this one's gonna be a
Subtraction.
minus, because that's a divide. And then what am I gonna do with that
Put it
2?
in front of the
Up
log.
front.
In front of the x, in front of the